So hello guys, this is going to be a quick GDB and Valgrind tutorial. Just as you know, you're going to have to install Valgrind and GDB from an external source. Um, I don't know how to do that on Windows off the top of my head, so I'll try maybe and find a link for that for you guys. But just so you know, GDB is going to be to help you find seg faults, as well as Valgrind is going to help you with memory leaks. Note that Valgrind cannot be used on Windows. It can only be used on, I believe, either Mac or Linux. But you can just use CodeGrid for the Valgrind portion. So yeah, but for GDB, it'll help a lot with seg faults and the fact that it'll tell you where the seg faults are. Now, for demonstration purposes, I'm just going to be using the lab2 main.c since that assignment's already complete and you can't submit it, so I don't think there should be any problems showing you it. Yeah, if there is, then rip my grades, honestly, because then I'll fail. But other than that, I'm just going to show you how to do it. Now, sorry for the Spotify. What's it called? To use GDB, because I'm going to start with that, considering that's cross-platform, everyone can use it in this class on their local machines. You're going to first have to compile it. So you're just going to run gcc main.c, and in this case, because I'm trying to do through lab2, I also have to add in the leak detector._c.h as well as the .c that .h relies on. But for the programming assignment, you're just only going to do main.c. But since we're trying to debug it, we're going to have to add some debugging arguments, of which are -O0 space -g. That's going to allow GDB as well as Valgrind to debug this, what's it called, a.out or a.exe. If you want to rename, by the way, a.out or a.exe to something else, you can just use the -O keybind thing, and you can call it whatever you want. So I could do haha, for example. I'm not going to because I like a.out and I'm fine with that. So I'm just going to do that. Now, if I look into my, what's inside of my lab2 folder, you're going to see all of these little things. We can ignore that. But most importantly, we have an executable called a.out. Great. Now what I can do is run gdb ./a.out for Windows. That's for Linux and I believe Mac. For Windows, it will be a.exe. I'm not on Windows right now. I'm on Linux, so I will be doing a.out. Okay, so I'm just going to press enter, and you're going to get into this little terminal application here. It's just going to be copyright, blah, 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 and no one cares. To actually start the debugging process, you're going to want to type start and press enter. This is just something since I'm on Linux, so ignore that. And we're going to start from here. Now, it's going to tell you here the temporary breakpoint was just started at the end of the file. That's normal. Don't worry about it. Breakpoints are completely separate, and for the sake of arguments, you're probably going to want to run the entire program from start to finish to see if there's actually any seg faults, to see exactly what the seg fault is. So, yeah. Now, as you can see, we're going to see that we're going to line 92. When I go to line 92 in my program, is int main parentheses right here. So that's where we're going to start at, which makes sense. Your C file always starts at the main function. Great. But how do we go to the next command? Because as you can see, we're just stuck here. That's simple. There's two ways you can do it. You can either use step, and that'll just go to the, in this case, the next thing. But if we were in a.texit, it would show us the exact things that a.texit is doing. I don't want to do that because a.texit is something that was given to us that we have to add. So I'm not going to do that. So I'm just going to go next, which is going to go here. And when I do next again, after that, after a.texit, it's going to go to the course lists, which is right here. Now, course lists calls the function read courses, as you can see in my main code. So I'm going to do next, and guess what it does? It's going to go inside of the read courses function, okay? So it goes inside of the read courses, and it initializes the variables, and we're in the scanf thing. So I'm just going to, input the scanf stuff. So let me get that up on my second screen because I forgot to do that beforehand. Sample in _1. Okay, so it's going to be 3, 4, 2 in my case. And then I'm just going to type in edel 10, 12, 9, 45. Oh, but you can see here that we had a seg fault. And we had it at a string copy. Oh, that's strange, by the way. This underscore string copy underscore avx2 is the avx2 is just my CPU architecture, useless. But it's telling you at a string copy of some kind, it's seg faulted because this is the assembly that broke it, by the way. It's just saying that we're trying to move to a certain memory area, and the memory out, and it broke. So some sort of what's it called? Some sort of thing at the string copy. It tried to move to a certain address, and it proceeded to segfault. In this case, I personally know exactly what went wrong, but since you probably won't, you can also use context clues in the fact that, okay, we were at the course list and we called the read courses function. So we know we were inside of the read courses function in its entirety. Okay, we know we were in this somewhere. We also know that we were at a string copy. Okay, so let me look for the string copies here. I have a string copy here, and in this case, this is my only string copy in this entire function. So it has to be in this line. We also know that we were trying to move to some sort of memory address. Okay, this is useless, but we were trying to move to some sort of memory address. So where here calls a memory address? We have last name, and we have courses I j plus 20 dot l name. Now, last name we got from what's it called? From just scanfing it. So I don't personally think that's the problem, and I know it's not the problem because I'm the one who edited this code to make it break. So I'm gonna look into this little thing here, and I can see that courses ij plus 20 dot l name. Let's see. I is just going to be, let's see, the name of courses. J is the number of students. Why am I doing plus 20? Because I'm on the first, what's it called? I'm on the first student, so the address of the thing should be courses number 0 as well as student number 0. But when I allocated the memory for the, what's it called? For the number of students, I allocated with just the number of students. So it should be from 0 to, in this case, 4, because I said there's 4 students. I'm currently trying to go to the memory address of 20 because I'm on j equals 0, so it's 0 plus 20. So I'm trying to go to 0, 20. That doesn't exist. And because of that, it's trying to access memory that the program doesn't have access to. So that's where it's breaking. By the way, to exit GDB, just type in exit, and it'll just say, oh my god, do you want to kill this process? Yes, you do. So I'm going to fix the code real quick. Oops. I'm going to fix the code. Boom, J. Great. So I'm just going to recompile it using the GCC function, GCC space main.c space, in this case, the extra arguments because we have leak detector, and then space dash 0, sorry, dash capital O 0 space dash G. Compile. And I'm going to run Valgrind again, not Valgrind, GDB again. Boom. So 3, 4, oh, whoopsie. That's my bad. You have to start. You always have to do start at the beginning. My apologies. Linux thing, it happens every time for me. Anyway, we're at int.main. Okay, I want to go to the next line. Okay, let's go to the next line. Oh, okay, let's go to the next line. 3, 4, 2. Ooh. Adele, 10, 12, 9, 45. Oh, it works. Does the second work? 6, 8, 9, 39. Oh my goodness, it keeps working. Now, for the sake of demonstration purposes, it will keep working for the entire program. So I'm just going to exit the program by doing Control-C. This works on Windows as well. This should work on Mac as well. And I'm just going to type in exit. Yep. And great, we're out of GDB. Now, just to show you that it does work, I'm just going to run the program, and I'm going to show you what the output is. And boom, it works. There is no segfault inside of the program anymore. Okay. So, because of that, we're going to head to the Valgrind section. Now, I'm just going to tell you ahead of time that for the Valgrind section, I got rid of all of my free memories. So this program is just allocating memory and not freeing it. So, and because this is my third time recording this video, I've stacked a bit of memory leaks. But how do I know what memory is leaking? Well, it's simple. You compile it using the same exact command, main.c space dash capital O 0 space dash G. You compile it, but instead you type in Valgrind. And I use this long command. You don't have to use any of this. So I will not for the sake of arguments. So let me just do that right now. So all you have to do is just do valgrind./a.out. Okay? And I'm going to just input in the sample, oh my gosh, I can't say it. Sample in like this. You can do this with Valgrind. You cannot do this with GCC. You cannot do this with GCC, this specific part right here. I wish you could. For some reason, they don't. Oh well, nothing I can do about it. So, because of that, I'm just going to pipe that in so that I can somehow get the correct output and use the same exact thing as when we did the, what's it called? Did the GDB. So, it got the same output, and that is the correct output, just FYI. That is the correct output. But we can see here that we have a heap summary. In use and exit, we know that we have 1,050 bytes that are unallocated. Sorry, that are still allocated. Okay? If this were to be fully, like, you freed everything and there's no memory leaks, this would say 0 and 0 blocks. Okay? Total heap usage, we can see we've allocated 60 things and we've only freed 31 things. If this were to be a fully memory leak-free program, it would be 60 allocated and 60 freed, with this number being big, because that's just the total amount, so it doesn't matter. As we can see via the leak summary, we can see that we have definitely lost 24 bytes in some block, and indirectly we lost 554 and 27, etc., etc. Now, do we want to see the full details? We do, so we want to run with this dash dash leak dash check. So let me do that. Let me just go here and type in dash dash leak dash check. Oh, I didn't type the dash dash check is equal to full. Okay, so I'm gonna run that. Boom. Now we can see something. We see that we lost this totality. This was definitely lost. We just never freed it when we should have. And we can see that we did it at a calc, at xcalc because of leak detector. If you don't have leak detector, this will not show up, this line right here. But by a read courses of main.c colon 34. So at 34, line 34, if I go to it, right here, of which is this entire line, like this, we'll see that this calc right here that I do was never freed. That's not good. So, but guess what? It didn't show the rest of the leaks. I only know what was definitely lost. So I want to show everything else, right? I mean, I want to know exactly what went wrong. So I'm just going to do show dash leak dash kinds is equal to all. And guess what? It shows a lot more now. We're going to show the indirectly lost ones. So we can see here, these were indirectly lost at 43 and 50. 43 being, what's it called? This one right here is what I meant. Not this one, but this one right here that I calc'd. 50. I calc'd this one and it broke and we never freed it. I keep showing you Spotify, apologies. And we can see all of them, even the ones that are still reachable, just like the one at the beginning, of which is right here. When we do this one and we do course list at malloc this, we could have freed that the entire time, but we didn't. So how do I fix this? Obviously, I'm going to use this, the release memory function. Now, because I'm, for some reason, on my little thing, whenever I import the leak detector underscore c.h, I'll show you here real quick by recompiling it, as well as doing this. It'll still show that I still have one that's still reachable. That's just due to the fact that the leak.h for some reason messes it up. If I were to get rid of it, it would it would show that it's free, everything's freed. But to just show you that one where everything's actually freed, I'm going to go to my programming assignment 1, which I'm not going to show the code of because that's cheating for all of you, and I'm just going to run the same command but with an alias in my case, since I don't want to type that all out manually again. It does the same commands as earlier. It does the GCC, okay, where is it? It does the GCC main.c with these two arguments, dash space capital O 0 space dash G, and then it does Valgrind, and then if you want to pipe in data, you can. I'm going to be piping in the sample in.5 in this case. So it's going to be doing that. Oh my god, don't worry, my output is not correct. That's just because I was doing debugging earlier than this. As you can see though, it says for my heap summary, in use at exit, 0 bytes and 0 blocks. Great. That means we're not using any allocated memory that we dynamically allocated. For heap usage, you can see that I have 44 allocations and 44 frees, as well as this is just the total amount of bytes allocated. And below that, guess what? No leaks are possible. All heaps are that were freed. We're good. I'm great. There's no errors. I'm done. The only errors I have is because my syntax is wrong because I made my function wrong. That's it. But other than that, I'm cooked. I'm not cooked. I mean, I cooked, you know? Like, I don't know. I don't know what to say. There's no memory leaks. And with that, I'm just going to end this video. So goodbye. I hope you learned something. If you didn't, just ping me on the Discord for CS, and I'll try and respond. But goodbye.